Alright, so here we are with Unit 9, Lesson number 7, and we're going to take a closer look at the pH scale, which we kind of touched on earlier in one of the lessons. The pH is a measurement of the concentration of the H plus ion in a solution. The more H pluses that are in a solution, the more acidic it is. The fewer H pluses in a solution, the more basic it is. And remember, the pH scale has two opposite ends. It ranges from 0 to 14. And remember, we said that less than 7 would be acidic, and that the strength of an acid increases as you go towards 0. And for bases, the strength increases as you go towards 14. So in many ways, they are opposites of each other. I don't know why that's doing that. And basically what we're doing here is, let me get rid of that. It's kind of summarizing what makes a solution acidic, basic, or neutral, and this is extremely important. A couple of things that you should remember: the brackets are concentration, so the way that you would read this is in an acidic substance, in a solution that's acidic, the concentration of H pluses, or you could say the concentration of H3O pluses, they're basically used interchangeably, is greater than the concentration of OH. And the larger the difference in these concentrations, the stronger the acid. In a basic solution, it's the exact opposite. The concentration of H plus ions or H3O plus ions is less than the OH. And the more OHs you have compared to H pluses, the stronger the base, the closer to 14 it's going to be. In a neutral substance, like pure water, what makes it neutral is that the H pluses or H3O pluses and the OHs have an equal amount, so they tend to cancel each other out. Similar to like when we talked about if you have an equal number of positively charged protons and negatively charged electrons, they tend to cancel each other out, and that's what makes atoms neutral. I'm not going to go through this stuff here. I am going to touch on the stuff at the bottom. So you are going to need a calculator that has that you can do log on. It's relatively simple. One of the things you have to be able to do is, if you're given the pH or if you're given the molarity of a solution, to figure out what the pH is. A couple of things to make note of. Notice that notice that one of the hints is that if you look at that compound, right away you can tell it's an acid. So you know your pH that you should get when you use the calculator should be less than 7. That's also an acid, also an acid, and also an acid. And basically what you do is you just press the negative button, then the log button, and put in this number, and that will tell you what the pH is. And the pH for this solution is going to be 0. That means it's a very strong acid. If they're asking you the pH for a 0.5 molar solution of H2SO4, you punch in negative sign, log, and then put in 0.5, and you're going to get 0.301 as the pH. The next one's going to be exactly, I believe the pH of this solution would be 2. That's a slightly weaker acid than this one. And then if you have a pH of 12, it's actually going to be a negative value. It's negative 1.08. That's an extremely strong acid. Notice it actually goes below the 0 line on the pH scale. Next is the pOH, which is the concentration of the OH ions. It's a little bit different. And what you do for that is you find the negative log of the pH, and then you subtract 14 from it, because remember this, we're talking about these are all bases now. So what you do is you plug in, and you might have, depending on the kind of calculator you have, 14 minus and then negative log of 1. So your answer here is going to be 14. That is going to be an extremely strong base. It's a pH of 14. What is the pH of a 0.5 molar calcium hydroxide solution? Is going to be almost 14. It's, I think, 13.7. What is the pH? This one's going to be strong also, is 12. And then the pH of a 6 molar KOH is 14.8. So that would be the strongest of all the bases. A couple of other things I want to point out to you is they really don't ever really give you much of these kind of questions here. Basically, what you have to remember is a couple of things. The pH plus the pOH always equals 14. I'm simplifying it, but I'm simplifying it because, well, that's the way they ask about it on the Regents exam. So this stuff here with the logs is really just for the honors class, not for the Regents class. So if they say to you that the pH of a solution is 6, then you know that the pOH, which is the concentration of the OH minus ions, is 8. That's got to be 14. It is literally that simple on the Regents exam. The other thing they might do is they might actually give you the concentration of the H3O or the H plus concentration. Okay. So let's say that the H3O plus concentration is 1 times 10 to the minus 4. The way that you would get the pH from that is you would just get rid of the 4 sign, the negative sign, and the pH of this would be 4. That's what they really do on the Regents exam. They don't really worry about this here. The other thing you have to remember is that if they give you the H3O plus concentration, like they did here, it's 10 to the negative 4. That means this concentration is 1 times 10 to the minus 10. So the pH and the pOH have to equal 14. You should remember that. And then these two concentrations should be 10 to the negative 14. And those are really the only two things that they worry about. The other thing you need to do is, and in this notes, they kind of really complicated it by doing what they did here, but we're going to go through it anyway. I'm just going to not even worry about what's at the bottom here. What they want you to understand is to be able to determine how much stronger two solutions are based on their pHs. And the pH scale, as you can see here, is at the bottom here, is a little bit different than what you're used to. It's more like the Richter scale, which is what's used to measure earthquakes. And what they're going to ask you to do is to compare strengths of two solutions. So, for example, if I ask you to compare the strength of an acid with a pH of 3 and a pH of 4, how are you supposed to do that? Well, the way that you figure this out is this. For every number that you move, it's tenfold difference in strength. So if you're moving in this direction to the left, every number you go from 5 to 4 to 3 is a tenfold increase in concentration or strength. So a pH of 3 is 10 times stronger than a solution with a pH of 4. Let's compare a 2 and a 4. A pH of 2 is 100 times stronger than a pH of 4. Right? So for every number you move, you're going to multiply by 10. So one number would be 10 times stronger, two numbers would be 100 times stronger, three numbers would be 1,000 times stronger in this direction. And it works basically the same way in this direction. A pH of 9 and a pH of 11, that would be 100 times difference in strength. The pH of this would be 100, this solution would be 100 times stronger base than a pH of 9. And I wouldn't worry about this stuff that's down here. This is what you really need to know, is this stuff right here. And that is the, in essence, the pH scale. This is just going through, and this is not something you really need to worry about, but it just gives you an idea of where some substances fall on the pH scale. It's not something you would see on the Regents exam. Let's go through the difference between what a strong and a weak acid might be. Remember we talked about when you put acids and bases in water, they ionize, they split apart. And the more of the particles that split apart, the stronger the base or acid it is. So when you take a sample of NaOH and put it in water, almost every single one of the NaOHs breaks apart into ions. Same thing with the HCl. That's what makes this a strong base and this a strong acid. A weak acid or weak base would still break apart, but not nearly as much. So for example, if you put 100 molecules of acetic acid, only a small amount of them would actually split apart. The rest would remain as intact particles. That's what makes it a weak base or a weak acid. This is just giving you an example of ammonia. Ammonia also, when it reacts, doesn't produce a lot of ions. It produces ions in a different way. It doesn't necessarily split up like these two, but this is also a very weak base. And that's pretty much it for this unit, for this lesson, I should say.